what are equations and what are inequalities. So, modulus functions, this is the important part, the part which we actually need to study. Alright, that was just the basics. Alright, now what are and you will get something like this. So, there are two ways to understand modulus functions. First is by reflecting it around the x-axis. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and let welcome everyone, welcome to today's class. In this class we are going to start off with another chapter, and that is going to be equations, inequalities and graphs. So without any delay, let's start. And the first thing we are going to do is we are going to study what are equations and what are inequalities. So what are equations? An equation is a statement that shows two mathematical expressions are equal using the equal sign to connect them. Alright, I am going to give you a very basic example. Right, this is like very simple and the basic example, but it does give me an idea what equation actually is. The definition was, an equation is a statement that shows two mathematical expressions are equal. So two mathematical equations are equal using the equal sign, So I have written what, like I have shown what I was actually given in the definition. Basically two expressions, both of them might contain variables, might not contain variables. I mean, there might be an example where one of them, or the left hand side might contain a variable, the right hand side might contain a constant. Still that will be called as an equation. Alright, next, what is an inequality? Inequalities are mathematical expressions in which both sides are not equal. In inequality, unlike in equations, we compare two values. So basically in equations, both the sides, okay, in equations, the part to the left side of the equals is known as the LHS, and this one is known as the RHS. So in an equation, the left hand side and the right hand side are actually equal, but in inequalities they are unequal, meaning they will be compared, either left hand side will be greater than the right hand side, or the right hand side might be greater than the left hand side. Just as a random example, 5 is greater than 3. This is an example of an inequality, right? Because these are my two sides, right? The 5 and the 3, and I am comparing them using this sign, which is the sign for greater than in this case, right? So in inequalities, we compare two values and the two sides are never equal. All right, okay, please note down the definitions. All right, let's move on to modulus functions. This is the important part, the part which we actually need to study. All right, that was just the basics. All right, now what are modulus functions? For any real number, the absolute value or modulus, so basically absolute value and modulus value are exactly the same thing, is the positive size, whether that number is positive or negative. So basically whatever my number is, my answer should be positive. That is basically the absolute value of that number. So if I am going to take an example, this is going to be my example, right? Modulus of 5 will be 5 and modulus of minus 5 is also going to be 5. All right, it also says it is denoted by a vertical line on each side of the quantity. See this line, these two lines, this is the sign for modulus. right? So this will be known as modulus of x. It's not n, it's x. All right, okay, so modulus of x. All right, okay, let's we'll move on. I don't think there's anything to copy here. Now, graphical representation of modulus function. How do we represent modulus function, and like how do we deal with it? All right, before that, I'm going to tell you something here only. Let's say my function is modulus of x, but I need to write this answer as a function without the modulus, function. I need to write it in normal function way. Now what I'm going to do is I'll break this function into two parts. Now what are those two parts, and how do we decide those two parts? Basically what I mean is this answer should be positive, right? Correct. So and if I'm removing this function size, these two values need to be positive somehow. Correct. If I removed the modulus sign, I want my answer to be positive. That's very obvious, right? So I want these two values to be positive. Now what I do is I break this function in two parts. How? I'll put this value that is inside the modulus function equals to 0, right? So I'll put x equals to 0. So the point 0 will divide my partition in two ways. That is, the first part is when x is greater than 0. The next one is when x is less than 0. Correct? Yes. All right. Now when x is greater than 0, I'll take any positive answer like 2, 3, 4, 5, and if I'll substitute that value here, I'm going to get a positive answer, right? And I do need a positive answer. Yes. All right. Now second, when I'll take any value from this one, let's say -3, and when I'll put -3 in place of x, I'll get a negative answer. Correct? I'll get -3 if I'll substitute -3 in place of x here. But my condition was that I need my answer to be positive. So what I'll do, I'll place a negative sign here. Now when you'll substitute x as -3, you'll get negative negative positive answer, and that's what my condition is. All right, let me give you another example. Right, so I'll put this value equals to 0. So what I'll get, x is greater than 2 and x is less than 2, right? When x is greater than 2, for greater value this function always opens like a normal function, so I'll get x minus 2 only. But when this function is less, right, for x is less than 2, what I'll get, minus of, always you can follow this thing, right? For the greater than thing, write the function as it is. For the less than thing, just put a minus sign outside the function, and that's it. All right, and now please note this down. All right, and using this logic, we are going to draw the graph of modulus function. Now y equals to mod x will be broken into two parts. Yes, that is y equals to x when x is greater than 0, and y equals to minus x when x is less than 0. Yes, all right. Now for x greater than 0, that is this part. That is this part, right? For this part, what I'll get, I'll be using y equals to x. Now what is the equation of y equals to x? Okay. This is y equals to x when x is greater than 0, right? Now, when x is less than 0, that is this region, right? So I'll get something like this. Not exactly. Fine. All right. So I'll be getting this function as my final answer. Now there's another way to understand this. What is that? So rather than drawing two functions, what we are going to do is we will be, just let me explain. Okay. Now rather than drawing taking in account for two functions, what you can do is just draw this function completely. All right. All right. Now what we are going to do is the part that was below the x axis, right? That is this part, right? This part. For this part, the blue part that I've done, I'll reflect it in the x axis, and when I'll do that, I'm going to get the previous part that I actually drew. All right, and you'll get something like this. So there are two ways to understand modulus functions. First is by reflecting it around the x axis for the part which was below the x axis. The second one was by distributing it into two parts and then drawing the graphs of two parts or two expressions separately. It's totally your choice which one you want to go with. But if I was me, what I would do is, if I have to draw the graph, I'll use the reflection logic. But if I have to solve a question algebraically, I'll use this logic, right? Because this logic is more of a algebraic solution. This one is more of a graphical solution. All right. So we'll always go for the graphical one with the reflection thing. And when we have to solve anything algebraically, we'll be using this logic only. Only when we have to solve algebraically, we'll use this logic. But if we have to draw a graph, we'll just draw the entire graph, and the part that was below the x axis, that is this part, will reflect it in the x axis. All right, please note it down. All right, before we move on, let's read this note too. Although I have said it, the graph of y equals to x below the x axis is reflected about the x axis. We did study that, right? All right, moving on to solve the equation 2x plus 3 equals 5 graphically and algebraically. So basically this is one of the most basic questions that you'll be getting in modulus functions. Whether it's graphically or algebraically, this will be one of the easiest questions. All right, now let's first solve it graphically. So what we are going to do is, we'll let this equals to y. So I'll get two equations. First, I'll get y equals mod of 2x plus 3, and the other equation that I'll get is y equals to 5. Correct? All right. Now Let's draw the equation of y equals 2x plus 3 first. Okay. So basically when I'll draw the graph, let's first name them. Okay. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and let's name this by minus 4, minus 6, minus 8, and 2, 4, 6, and 8. All right. Yeah. So when you'll draw the graph of y equals 2x plus 3, you'll be getting something like, yeah, hold on. Okay. Something like this. Yeah. All right. Not exactly. And the part that was below the y axis will reflect it, and we'll get something like this. All right. That's the graph of y equals 2x plus 3. But remember this, you'll be getting this line by using y equals 2x plus 3. But you will get this line by using y equals minus of 2x plus, there's this difference, right? Because this part we got by using the second one, that is y equals 2x plus 3, and the second one will be y equals minus of 2x plus 3, right? So this part is from this equation. Okay. All right. Now let's draw y equals to 5. So y equals to 5 will be a line on something like this. All right. So I have two solutions. Now how two solutions? The pink line and the yellow line and are intersecting at 2 points. The first one is this, second one is this, right? So how to solve the first one? Check graphically. What is the point? 1 comma 5. And what is the second point? Minus 4 comma 5. Since we are getting an exact value, we can answer it out, right? All right. Next one, that is algebraically. How to solve it algebraically? Whenever we are talking about a modulus function on one side and a constant on other side, all right, what we'll do is we'll break our function in two parts the same way, that is 2x plus 3 equals to 5 and minus of 2x plus 3 equals to 5, right? Now what I'll do is, in the second one, I'll take this negative sign and place it on the negative 5, and I'll get 2x plus 3 equals minus 5, right? Let's solve this. Let's shift it there. I'll get 2x equals 5 minus 3. I'll get 2x equals to x equals to 1. And the next one I'll shift it there. I'll get 2x equals minus 5 minus 3. So that gives me 2x equals to minus 8. So x equals negative 4. So my first point becomes 1 comma 5. Second point becomes minus 4 comma 5. And see, I am getting the exact same answer, that one also. All right. Okay, please note it down. Next, Solve the equation mod of 2x plus 5 equals mod of x minus 4. Now, remember one thing. In the previous question, I gave you two methods, right? The first one was graphical, the second one was algebraic method. That method will be used whenever you are having modulus on one side and a non-modulus on the other side. The non-modulus thing can be a constant, it can be a function, but it should not have a modulus sign on it. All right. Okay. Now, how to solve it? We'll plot the graph of this one and this one. Fine enough. So let's plot the graph of 2x plus 5. So I'll get y equals 2x plus 5. Let's draw that. So 1, 2, 1, 2, 3, 4, minus 1, sorry, minus 1, 2, minus 3, minus 4, 1, 2, 3 and 4, minus 1, minus 2, minus 3 and minus 4. Now, to draw the graph of 2x plus 5, you'll get something like this. Okay, hold on. Yeah. Now, if I'll do the same thing for the negative thing, I'll get this. That is the graph of y equals 2x plus 5. Now, let's draw the graph of y equals x minus 4. Hold on. Yeah, fine. Now, y equals x minus 4. Let's change the color. Okay. So, I'll get slope as 1. This is the point, right? And x equals to 4 is the point of intersection. So, my equation will be something like this, and something like this. All right. Now, the problem here is I am getting one point, and that is again not a perfect point, right? But the problem is I'll have two solutions. What is the other solution? And since I can clearly see it's not happening, so where will it happen? That's my problem right now. How to solve that? Now look very carefully. The pink line, this line I'm talking about, okay? This line is like more steep, right? It's increasing rapidly. And this yellow line, it's not increasing that rapidly, it's like a bit down. So as much as I'm going to extend them, they're going to, like be more further apart, right? So this pink line and this yellow line are never going to meet. Yes. So now let's talk about these two. You can clearly see in the starting the distance is this much, right? But now their distance is only this much. So I can say that at some point they are going to intersect, right? So my another solution will be from this line and this pink line, right? So I'll have two solutions. One is this one. Again, I cannot be sure, but I can say that the equation of this line was 2x plus 5, and the equation of this yellow line was minus of x minus 4. That is the first one. The second case is from this equation, that is minus of 2x plus 5 and minus of x minus 4, right? Now let's try and solve this. What I'll get, 2x plus 5 equals minus x plus 4. Let's shift it there and let's shift this one here, and I'll get 3x equals minus 1, x equals minus 1 over 3, right? And if I'll substitute x as minus 1 over 3 in this equation, so I'll get y equals minus of minus 1 over 3 minus 4, that is minus 12 minus 13. So y will be 13 over 3. So my first coordinate becomes minus 1 over 3 comma 13 over 3. That is my first one. Now let's solve the second one. Let's cancel out the negative and the negative, and I'll get 2x plus 5 equals x minus 4, right? So let's shift it there and let's shift it here. So I'll get 2x minus x equals minus 4 minus 5. So I'll get x equals minus 9. And let's substitute my x as minus 9 in this equation, and I'll get y equals minus of minus 9 minus 4. So I'll get y equals 13. So my answer, second answer is minus 9 comma 13. See, I am getting two separate answers. Now, how to recognize how many solutions will be there? Whenever we are talking about two linear equations, in case of modulus functions, you will always have two solutions. You just need to figure out which line will be giving you those solutions, right? Now, why did not I do the algebraic method? Because when you open a modulus sign, you get a plus minus on the left hand side, you'll get a plus minus on the right hand side. So basically you will be solving 4 cases, and that will be very much like confusing. So that's why we will always avoid using algebraic method whenever we'll be dealing with 2 such cases. All right, so please note it down. Cut. Cut. All right everyone, so that's it for this class. We'll be continuing this chapter basically in the next video. So please keep practice and watch this video carefully. Do practice some questions and practice especially this last question that we did. Practice some more questions related to this topic. All right, so let's see you in our next class. Till then, stay safe, keep practicing, and thank you. If you had a blast watching, give us a thumbs up, share it with your friends, and subscribe our channel to stay updated on all our future videos.